Hello. We are going to talk about functional programming. Got a nice, cool vibe in here right now. It's a little bit dark out. It's a little bit dark in here. It's nice. So by the end of this lesson, you should be able to refactor programs using functional techniques, at least a little bit. So this is carrying on from our discussion yesterday of paradigms. Can anybody tell me a summary of what they retained about object-oriented programming? Let's put together a list. What were some OO ideas? Classes. And you can't talk about classes without talking about objects. Cool. What else do we remember from OOP? Time. Concept of time and state kind of goes along with that also. What state is the application in at this time, and this time, and this time, and this time? What else? Yeah, so we talked about prototypes. We talked about static versus instance. What else? Inheritance. What else we talk about? Behavior. Talked a lot about state and behavior. What else?
The difference between procedure, function, and method.
Yeah. Proc, functions, and methods. What was a method?
Procedure that's owned by an object.
There you go. Love it. Any other things you remember about AOP?
It's a hack on the original functional JavaScript.
I know what you're talking about now. Yeah, JS is kind of like neither nor. So a little bit more on that. This kind of interesting thing happened with JavaScript about 4 years ago, a little 5 years ago. And the idea was that we need to make sure that JavaScript can keep up with Java and C# and the OO languages. And so we tacked on things like the class keyword and things like async await. And all those came out of this desire to like really finally make this a robust OOP language. And at the same time, we got things like fat arrows and the spread operator and a variety of things. We're like, we need to really just go whole hog on the functional thing with JavaScript and just make this a robust functional language. And the tension between those two things carries on to this very day. And the legend goes, if you listen to the whisper of the winds in the night, you'll hear people saying like, classes are ruining this language. And so, yeah, it's a little bit bolted on because JavaScript was never intended to support like class style OOP sort of shit. And so really the class keyword is not like the class keyword in Ruby. It's sort of papering over a related pattern. But if you get a job writing Java or some OO kind of stuff and it doesn't work quite the same way it does in Java, I told you so. Cool. Anything else you remember about OOP and JavaScript? Perfect. So now we're going to go to the other side. We're going to talk about what makes something functional. So what I'm going to do, this one's a little bit more vocab heavy, I think, than OO stuff is. And I want you to spend, I'm going to put 7 minutes on the clock. And I want you to come up with as many concepts, vocab words, core ideas around functional programming as you can. And off to the races. Go! Alright, table discussion. So, 3U, 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 2 U's. Discuss what you found.
Pure functions,
Where it's like you have like just like a simple side variable that deals with and then the function says take that out.
So side effect is,
Instead of like returning that variable.
anything
you
that's
just return
doesn't fall into being
from the
that.
vector.
So, like displaying something
And
else.
then people should
Both the functions on one side. Like if you're doing math, let's say you take an array, change like everything somewhere else, it'll give you an array. So you're still getting out your putting out an array with the same one. But now if you're doing a log in an array, like a for each statement, or something, now you create this outline, put it on the screen. Now you're
Yeah,
creating
well, it's
this
more just like a block or some truth that like you can dissect. Or like a console abstract it out.
Wrap up your discussions. All right, back with me. So, someone from this table, what's a principle of functional programming you found?
pure function.
Pure functions. What's a pure function?
A pure function is given the same inputs, always returns the same output.
Cool. Is there another word for that? You already know?
Deterministic.
Thank you. So we can determine what the output is given an input. It is deterministic. We also call this purity. I want to stick with purity for just a second. What are some other things, this is for anybody, that you found about functional purity?
It seemed like a related concept that I'd actually look at with referential transparency.
That's my favorite one. We'll talk about that one next. Referential transparency. Let's stick with pure functions just a little bit more. Other things that you came across when talking about purity. Ethan.
Easier to test because it always gives that same output.
Yes. Much easier to test. You can test things that aren't pure, but then you need to mock the environment around them. You go, okay, as long as this is executing in this environment, does it read this thing out of it? Does it change it to this value? That becomes increasingly more complicated the more complicated the environment you're running it in is. Versus, if I just got to make sure that if I put in cat, I get back tack, that's a lot easier. What are some other things about pure functions?
No state change or no side effects.
Side effects. This is big. No, so I'll say, fuck, why is that not working? Side effects. Nuh-uh. What is a side effect? Yeah.
Some people called it only happens on Tuesday afternoons, but.
Nice. Side effect can be even smaller than that, though. We use them all the time. We have to have side effects in our application somewhere.
Change like a global state or like some sort of variable that's higher up.
Yeah, if you're changing a variable that's not within the function you're working with, that's a side effect. Updating a counter that's outside of this, that's a side effect. There's one super important side effect that we have to have at some point for any of this to mean shit.
Console log.
Console log is an example of this.
Interactivity of some kind?
You're right in the ballpark. I gotta have some output to the screen. That's a side effect. I can't return out of a function to my screen. There's something that takes some kind of accumulated value and then displays it to me. That's a side effect. In functional programming, we try to minimize side effects, but if there's no side effects, it doesn't do anything. So what we ultimately want is to push those side effects all the way to the end of the application. So we do all of our calculations and then our side effect. Because then we can really easily cut off the side effect and make this testable. Pretty cool. Neat. This table, give me something you found about, well, I'll come back to referential transparency in a little bit, but what's another FP principle you found?
Is it us or? Sorry.
No, this table.
Functions can be higher order functions or first class functions.
Higher order and first class.
Or first class, but
Oh,
they
yeah,
can be.
Let's pull those words apart a little bit. What does it mean? This is a question for anybody. For something to be a first class function.
You toss around like a variable.
Mm-hmm. That's it. Think about when we were writing Ruby. We couldn't do that. Methods come with classes. There's no like, I would like to save this method in a variable and pass it to this other class. It's not a thing, right? Or think about that neat trick we do where we pass a function definition into a map. There's an almost similar idea in Ruby that we never really talked about called procs, but OOP languages generally do not have that as a concept, first class functions. But yeah, being able to store that in a variable, pass it into a function, return it out of a function, that is what higher order means. Higher order means that we can, if we have a first class function, we can pass it in as an argument, we can return it out as a return value, or we can do both. That's higher order. Cool, back table, what's something you found? We have not talked about everything, all things FP yet.
Recursion, you can't do
Yes,
double loops.
correct. Recursion is our go-to for looping. Why? Mm-hmm.
Through looping, then you're mutating a variable over and over again, which is all that.
Yep. That little incrementer, that's mutating. We don't like that. And also, we're kind of back to that concept of time. First time through the loop, second time through the loop, third time through the loop. With recursion, what we're saying is like, hey, if you call this function, you'll get this value back. You can do deterministic, very like expressive functions that also call themselves. Anything you can do with a traditional looping mechanism, you can also do with recursion. It's a little bit trickier to wrap your head around. I know that some of you have done recursion labs. What's the magic trick with recursion? How do we not just get in an infinite loop?
Set timeout is one.
Okay.
Is it break?
Hmm.
Do you need a condition?
What's the condition? It has a special name.
The ceiling.
This.
Look it up, everybody. When do you stop recursing?
Termination condition.
Yep. Has a more elegant name than that though. Shout it out when you find it. Starts with a B.
Base case?
Base case. So when we're writing a recursive function, we have a base case. And so like the base case might be something like there's nothing left in the list. If there's not nothing left in the list, call this function again with the remaining values. So usually what you're doing is working with a head and a tail. So the head is like the next item. That's the one we're working with. And then we sort of take that off at the end. We work with this. And we go, cool, how long is the tail? Is it more than 0? Okay, cool. We'll pass that into the function again. And then that function takes off the head, works with the head, passes the tail. And so we start chopping off that tail until there's nothing left. And then we've met the base case. And we return all the way up. So one of you ran into the Stack Overflow problem. Who was that? Is it Rob? Cool. Right. Do you what did you find out about tail call recursion, trampolining?
I took notes to look at it later because I was
Okay.
other stuff.
So the problem with recursion is that as we're doing this, the function calls itself, calls itself, calls itself. We kind of get into this these are all these function calls, but all of this stuff is in process because the return value of this one out here was going to be the return value of this one, was going to be the return value of this one, was going to be the return value of this one. So what you end up with is all these little micro instructions that you're doing, those go onto a thing called the stack. This is instructions for the computer to operate, to execute in order. I would like you to do this, and then this, and then this. Oh, we added some more stuff to the stack, and this, and this, and this, and this, and this. And with recursion, very quickly, you run out of stack. There's a finite amount of it that your browser will let you do. And if you run out of space to do that, it's called a Stack Overflow. Oh, shut up. So there are solutions to that. I would say not too many of them work particularly well in JavaScript. That's a language limitation. Python, Scala, lots of languages have more elegant ways to handle that from blowing your stack, but that's how we handle looping in functional languages. Cool. This table, what'd you find?
Functions are based on the lambda calculus.
Ooh, very cool.
First principle is that they can all be written anonymously without a name, and they all go through creating which I didn't really get to.
Cool. So this is my awful attempt at a lambda. So the lambda calculus was early-ish 20th century. This guy named Haskell Curry was a big part of coming up with a way of expressing transformations as series of functions. And currying is a pretty interesting idea. So currying is the idea that if we have these higher order functions, these functions that return functions, then we can successively, I think it's easier to understand if you just look at it. If I have some function and I call it, but the thing that it returns is itself a function, then I can call that. And if the thing that returns is a function, then I can call that. And so when you see something like this, you're currying. And usually what's happening is you're gradually building something. And so think about a function that takes 3 arguments. Well, you guys have played around a little bit with bind already, right? So what if, bind, somebody who has done something with bind, explain it. When I do some function dot bind in JavaScript, the first value is
The object that you want the state of this to be put up, right?
the this value
Yeah.
in that function.
Yes.
What's the next argument to bind?
Next. The function.
The function that you want to bind to this.
Nope.
This,
I'm calling it on the function I'm trying to bind this to. So I've bound this, but it takes more arguments.
Isn't it related to the context in which it's going to be?
Nope, simpler than that.
It would be really eloquent with then, is it?
No. Jesus. That's good. I like that.
The arguments that the function takes?
Yep. I can pre-apply an argument to a function. That's the first argument, that's the second argument, and so on. So if some function takes 3 arguments, before I call it, I can bind to this value, I can bind its first argument, and I can bind its third argument, and then I do some func, and all I need to pass in is the third one. And so in practice, a lot of the time what that looks like is you'll have these teensy tiny functions that only do part of the function. They do things like apply one of the arguments, and then you call all the functions that get returned from them. It's called currying. I wouldn't worry too much about it right now, but the first time you see a function look like it gets invoked 3 times in a row like that and you lose your mind, there's a word for it. All right, I want to talk more about referential transparency because this is, I think, my favorite FP idea. We talked about it a little bit yesterday too. Referential transparency is the idea that these 2 expressions are the same thing. And so is that. A function call is equivalent to its return value. You can use them interchangeably. Anything you can do with one of them, you can do with the other one. So like, if I would do type of 2 and I get back number, I could do type of this and get back number. If I do, what's some method that I can call on numbers? Floor. That's the thing that you can do with numbers, right? And I can also do it on that. If I have some array, well, I can either do something like store that in a variable and then do a.map, or I can just call map directly on that. They have referential transparency. An expression and the thing that it evaluates to are the same thing. Sit with that for a sec. So if we think back yesterday to this concept of time in procedural programming and OOP programming, we're doing this, storing this in a variable, stop. And then we're doing this with this variable, stop. And then we're doing this. We have this sequence of things. The reason we don't have that same concept of time in functional programming is because this array, and then we map it and we pass in the double function to it, That is the same as if we just had an array with 246 in it. We're much more in the realm of statements of fact than procedures that the computer executes. These two things are the same. It's fucking nuts. Tyler?
So, the problem I have conceptualizing this is that, like, you know, like, if it's a function, it still has to think for a second before it knows its value, right?
Sort of. Like, we exist in a world where time is a real thing, and it takes a finite amount of time to get through this. So yes. Conceptually, no, though. Since these are statements of fact and these two things are equivalent, even though the computer literally takes time to process it, there's no break in the instructions. And since our functions are pure and executing a function doesn't change anything anywhere else, we can just treat it as that value. Pretty cool.
So you're saying it's not an order of operations thing?
Yes. Yep.
Wait, what does that mean?
So with procedural programming, we have like an order of operations, right? We do this line, then we do this line, then we do this line. We don't have really the same constraints with this. Since we're dealing with like statements of fact, it doesn't really matter what order these things happen in. They're, because of referential transparency, these two things are just the same.
Aren't they the same when you declare it in a, if you just declare a function, you say constant, I mean,
Well, let's go through it this way. This might make more
like
sense.
in Ruby, if you declare a function and you set it equal to that map.double, every time you, or sorry, if you declare a variable, every time you call that variable, it's gonna equal whatever that is. It's gonna equal 246.
Right. So I'm going to do const numbers we're going to do this procedural style. And I'll say and then I'll say all right, so we're going to iterate through each of these, and we're going to say let new number equal numbers dot shift. And then we say doubled numbers dot push new number times 2. Okay, that's the procedural way to do that. And I don't know why my Zoom isn't working. Is it control, negative, minus, up, down? All right. So think of these steps that we have here. This happens, the computer stops. Then this happens, computer stops. Then we go, okay, I'm going to initialize this. Then I'm going to check this. And then I'm going to do this. And I'm going to do this. And then I'm going to mutate this. then I'm gonna check this, and I'm gonna do this, so on. That's the procedural way to handle that. And that's what I mean by there's a concept of time. We can pause at like various points in the execution of that program and examine the state. You really don't do that with this. There's no points to pause at. Yeah.
So that function right there,
Yep.
when you read that map double, that is a function in Ruby that you can call, and you can have A and throw A around anywhere, and you get 246 whenever you call that.
Oh, I know you're not. So that's the procs thing that I was talking about. So you can do that in Ruby. That's a thing that like they pinched a little bit from FP. It's the same thing with the concept of blocks. Like up until Java 9, I think, Java didn't have that either. Turns out life is really fucking hard without being able to do these applicative sorts of things. And so a lot of the OOP languages, as they've been dusting off their enterprise FizzBuzz, have been kind of taking on some of those sorts of ideas. But yeah, that idea of like saving a function with a thing applied to it and then calling it on something else later, that's hardcore FP. All right, let's get a little bit more concrete. So we're trying to refactor programs using functional techniques. And if we look over at the assessment for that, we want to take this code and refactor it until it has no declared variables, no mutable state, pushes side effects to the end, uses pure functions, and uses no anonymous inline functions. So I think when Kat was talking about the lambda calculus, it's like our functions don't have to have names. That's true, but not an old man code release house. Your functions are gonna have fucking names. So this is what we're trying to do. I'm gonna ask you to give this a shot. I'm gonna put 5 minutes on the clock, pull this down, see if you can torture this until you've met all of these criteria. Go. No. Well, like, it might be under the hood, but it isn't in JavaScript.
Cool.
You crazy. Cool, so we just want.
Part of the neat part of that is who gives a shit? Like, it's all abstracted away.
That's true.
Another minute and a half? You think you did it? Fucking know it all.
No, true.
What are we talking about side effects?
Is that side effect? Absolutely.
This is crazy.
It's happening.
What's the side effect?
It's happening in the state.
Just return action is.
So that's a side effect.
Just return it.
Correct, so you have to do it all.
Oh, I see what's going on.
Yeah, but then we're gonna like,
You just do it.
Jackson. Just do it. Oh,
Bam, yes.
We're good. Got it.
You got it?
You got me modified. I love modified. Function.
All right.
So.
Shut up. So, let's work through it. Saw some pretty good ones. I think Jeremiah got it. So I'm going to call this FP practice a touch. You guys are having too much fucking fun. Okay, so no declared variables. All right, so I don't want this teacher's business. I want just the list of teachers. All right, and then this pattern, every time that we're doing something like that, what do I want to do?
Map.
Yeah. Good on you. So then I take teacher, and I take this thing that it's trying to do here, and I return teacher plus exclamation point.
There's an extra F there.
Good call. All right, I no longer have any declared variables. Do I have any mutable state? No, but I'm also not logging it anymore. So I could do something like that. All right, any mutable state in here? No. Does it push side effects to the end? Why, yes, it does. And this is the thing I saw missing out of a lot of yours. You want, you don't want to do it in the map. You want the entire transformation to happen, and then you want to log them. Uses pure functions. Is there any? Nope, that's good. Uses no anonymous inline functions. This is the other one that I saw. Those fat arrow functions, those are anonymous inline functions. So we want to extract those out. So we get something like Loudify. And Loudify doesn't have to be a teacher. Really, that just takes any string and adds an exclamation point to the end. And so we can do something like that, or even better, something like that. And now, instead of that, I can just say map Loudify. Dope. And for this one, to get rid of that anonymous inline function, I have a shout that takes in a string and logs it. And there we go. No anonymous inline functions. So we take the data, we map through, make a transformation, and then we have our side effects. That's what that looks like. This is procedural, functional. Questions about that? Okay, I'm gonna show you one more way that we can take this even further, and hopefully if like this functional thing is awakening something in you.
Could you
Yeah.
do this in one function with reduce, or just one?
Not and push the side effects to the end.
Okay.
So
If you, so let's say reduce was returning a string, well, I guess that would be the same either. Never mind.
So I'm gonna install Lodash. And we've talked about Lodash before, have we not? Never? Yes, no? I'm gonna take that as a no. So Lodash is a collection of little teensy tiny functions that do all kinds of awesome things for us. So for example, when we were talking about heads and tails and recursion, here's a function to give you the tail. It things like unique. We can take an array and get only unique values from it with that function. It's pretty cool. And then there's some that we already have in JavaScript, like for each and map. The baller thing about those in Lodash is they work on collections, which include objects. So you can map over objects like you could in Ruby. Pretty dope. And my absolute favorite part of Lodash is it has a library called FP in it that is the same functions in a more functional way. So we're going to require Lodash FP, and we're going to bring out map for each and flow. And then what we're going to do, what flow does is flow is a function that takes an array of functions and then applies them to some data. And in true functional fashion, we're going to curry that data. So we say, I would like something that loudifies and then shouts. That's the most FP thing of all. And the most baller part of this, We could still extract out that data. We could say those and make this a function called loudify and shout. And now we just have that. We can reuse it. We can take any array of strings, add an exclamation point to the end, and then log it. So we can go loudify and shout, teachers, something else, whatever. That is sick. Because we've taken these teensy tiny little one-line functions and we've made it so that we can compose them into more complicated structures.
Could you modify and shout recursion? So that just infinitely adds.
Not in JavaScript. That's just going to be my answer for everything from now on. Not in JavaScript. So, oh, and one more thing, because this might make this click for some of you. So this is the time-based way to do this. We store this, and then we use it here. The exact same thing curried. And now we're no concept of time. Now we're back to expression evaluation.
So flow is taking modify and shout and iterating in turn the array that you passed in the curry.
Oh, actually, shoot, that's right. So for this flow to work, it actually needs something like loudify all. That takes in an array of strings and then takes array of strings and maps loudify on each one of those. All flow does is call this function on whatever you pass into it and then carry that on to the next one. So same thing with this one. We do a function shout all array of strings and then array of strings for each shout. And then this one becomes shout all. So the way you'd read that is this is the input. It gets passed into loudify all. Loudify all does its magic. Its return value is the input to shout all. And then if that had an output, that would be the result of flow. Dope.
So could you return at the end of flow, or is it automatically?
Well, you could, but in this case, the thing that comes out at the end of this is console logs. So you get, and it's a for each, so it comes out as undefined.
So in this behavior, at each state of the loop, it's console logging. So that behavior isn't necessarily put all the way to the end. It's just expressed at the end.
So the last thing that happens here is all these console logs, but no more transformation. So we just have side effect, side effect, side
The
effect.
strings have already been made.
Correct.
And now you're just saying. well,
Exactly. And that's what makes that testable, because we can just sort of chop that off and go, cool, did the transformation work? All right, cool. Now we just poop it out to the screen. More questions about refactoring programs using FP. Yeah, Jeremiah.
Is like companies that use FP over OOP, do they run into like situations where like no one really understands what's happening? I don't know. It seems like as
Sure.
the code base grew, it would get harder and harder to trace back any problems that happen.
So my answer is going to be not the way that you might think, because the level of confidence that you have in something like this, there's so much like less, oh, well, this mutates this thing over here, and so we have this spaghetti web that we need to trace every time we do something. Little tiny functions, and so it's so easy to trace the output on them. You don't have to worry about what else they might have done, because the answer is nothing. I'd also like to thank you for that alley-oop, because we have Becky here. Becky is a Scala dev. Can you tell us about your experience, like working with some of this stuff out in the wild?
Yeah, so the implementation of Scala doesn't have to be functional organized, but that's how we use it. That's how many people use it. And I do front-end development as well. We use React and Redux, and our approach is functional there as well. And it's a good question, because I came from, I did a couple years, 2 to 3 years of Angular development prior to that, and our approach was object-oriented. And I think because that sort of reflects reality in a different way, like the way that humans think of reality, it's like, oh, I'm never gonna be able to understand this, like functional programming, it seems so much less intuitive. But Kyle's right, like the predictability that you get with functional programming is invaluable. I saw it a lot more on the front ends too, where like you actually see situations where you're, this function that you forgot existed or didn't even know existed, change something, and then you like see it in your UI and you're like, what the heck? Like why does that look that way? Why did it change? And then you have to trace back and figure it out. But here you're essentially making a promise and a commitment to the code, to other developers that like this concept of immutability, that things are not gonna change. And it really does make things much more predictable. And then another nice piece of it is this concept of like imperative versus declarative programming. And so like in our code, we don't use for loops at all. And the benefit of that is if I see a map function, and I've never even seen the language before, I have a good sense of what that's gonna do. And I have an expectation of like what's gonna be returned from that. And so if I see a map or a reduce or a flat map or these other things, it gives me a context immediately, as opposed to like, I see a for loop, I know it's iterating through some collection and then it's doing something to it, I have no idea what. I don't know what the outcome is. So it's almost like, I don't know if self-documenting is too strong of a word, but like in a sense it is. Like it provides a lot more context. And you end up running into many fewer issues I've found. So I've become more of a proponent, even though it's a less like tangible, real world way of thinking about code.
I love that. So a really good example of that is if I see map Loudify and I have a sense of what Loudify does, it's like, okay, I know exactly what's happening there. With that for loop syntax, there's like 8 different places in those 3 lines for an error to hide. You have off by 1 errors, you can have an uninitialized variable, you could be incrementing instead of decrementing, you could do so many things wrong if it's just map with this function. It's like, I'm gonna get back an array and it's gonna apply this to every single item in that collection. And so it's such a dense way to communicate to the computer and more importantly to other people on the team. The trade-off is that like you need to develop this vocabulary because people don't talk about maps and reduces like in the real world. So, and then at some point you end up with becoming one of these assholes. The category theory stuff. But if you can use this language fluently, the density of like information you can communicate with any of these words is tremendous.
What's a centoid?
Why am I alone?
I believe it's pronounced cetoid, and that's all I know about it. Of the things in Fantasyland, I know applicative. That's it. And an applicative is things like map and reduce. They are applying a function to a collection.
Cetoids are studying especially in proof theory and type theoretic foundations of mathematics.
There you go. Jackson.
Does functional programming also just like scale and operate better in a, is it quicker? Is it like performance-wise, is it an advantage over OOP?
Can be. It's usually a lot less memory intensive, because if you're not storing all those variables, there's not a whole lot of memory to use. There's no concept of time. We don't need all this intermediate state. However, trade-off, and this is the case with most computing you'll do the rest of your career, you're always trading off between memory consumption and CPU consumption. So way more computationally intense. However, there's a side benefit to that with scalability. That computational intensity, if you don't have to share memory, now you can split up that work. You can say, hey, I have this intense calculation, these 8 computers get cracking. And then they work on the result, and then you get it. If they don't have to have one like consistent data source that they can all talk to, that becomes possible. So in that way, I'd say it's more scalable. But it is almost always more computationally expensive. And shit, even just look at this. Really, we're going over the same collection twice when we could have just mashed it all together into one thing. That would have been more efficient. But now we can't build things out of small composable functions. So, yeah.
Can functional programming break if it has to have side effects, like you have to interact with the database or you have to make network requests, things like that, where you're expecting promises that come back in different ways? Like how do you catch that?
Sure. So functional programming isn't a noose. It's a tool. It's a way to keep yourself from making mistakes. It's not like never access a database, never print to a screen, any of these kinds of things. But if you can do things like that database request, if you can group all of that together and so that you get the data and then you just put it through this pipe and you have this pure pipe, we've got side effect here, that's a lot better. That's the attitude that FP is trying to like get you to take. Cool. What else?
I have like a general question kind of for both.
Mm-hmm.
So you're talking about how things are equal to each other, like the function would be equal to like the
Yeah.
operator.
And real quick, what's the vocab word for that?
Pure intrinsic.
Nope.
Referential transparency.
Referential transparency and expression and the thing the expression evaluates to are equivalent. Okay, keep going.
So would that be true in like memory as well? So if you have like A equals 2, B equals 2, C equals 2, would those all use the same like address in memory?
They use the same address at memory.
Or just like concept wise?
I would say these are not equivalent. Also, once it's like getting stored in memory, you have almost no confidence that it didn't get changed somewhere. that's one of the reasons that once it's getting stored, the transparency doesn't exist. Time?
Time check?
Yeah.
How much time do you need?
We're wrapping up.
Okay.
Couple minutes.
I'll tell David to wrap it up too.
Cool. Oh, he got it working?
I don't know, he just sent out a Slack at 3:30 being like, let's go!
Awesome.
Yeah.
He was having the Ruby Blues. And by the way, just a minor editorial. Gem is the worst fucking package manager like I've ever seen.
Oh, interesting.
It is a hot piece of shit.
Just know very easy to overload.
The fact that like it's installing all the gems in just some part of your computer, not with the project, thumbs down.
Kat helped me out with that at the beginning, cause I had like set up a different, she's like, you need to bulldoze that entire
Yep,
thing.
that sucks. The way that it resolves versions is not deterministic. Sometimes I feel like I'm hosting a kid show. It's like, and on today's episode, listen for the word deterministic. It doesn't do like deterministic installs. So like doing a gem bundle install at like different times will give you different versions. It's stupid. And the syntax is dumb. Just I do not like that package manager. Cool. Other questions about functional programming? Yeah.
So, is it encouraged to like keep all of your logical operations separately from like things like making requests and getting objects from users?
Oh,
Or just,
you're
like,
getting it.
Files specifically for your logic,
Yes.
and then have everything else do your object-oriented stuff?
Yes.
Okay.
So when I was working at the at Health Scholars, I primarily worked on a calendar app. Let me see if I can find some pictures of it. Nothing. Screen. No. Let's see. This would have been like January of this year, I think. That was December. Here it is. Okay, so this was the this is the app that I worked on, and essentially what you did is you said, I want to schedule a class. The room that I'm doing it in needs to be VR capable and have like an air pump in it. It needs this piece of equipment. This person definitely needs to go, and any 3 available instructors. So you put these, and it's an hour long. And so you put these constraints on it, and then what happens is it goes into the database and looks at everybody's availability and all that kind of stuff, and then gives you available times that you could schedule that on. So what I did is I just returned all the availabilities back from the server, and I did all this number crunching on the client, which there's trade-offs with that, but it was crazy responsive. And the way that I did it is I took all these availabilities and all of these little filters and just ran it through a monstrous functional chain. But by monstrous functional chain, I only had a single function that was longer than 2 lines. There was just 300 of them. So much easier to test though. I know exactly what each of those little tiny pieces does, and then it just becomes one of these things like, okay, well if that works and that works and that works, then together they all work. Cool, test pass. And so that was just a separate module in the app that by the end of it, it's just this giant machine that takes in this and poops out those. That was a fun app. Yep.
I actually was just gonna ask you this later, but yeah, so I'm doing not the same thing at all.
Mhm.
But a ton of number crunching and logic on the client side,
Mhm.
that's okay.
Yeah. So like you just need to keep in mind like what trade-offs you're making. So if that's happening client side, it's happening on your user's computer.
Yes.
So are they likely to have a device that can do that? How many of them are going to be on phones? Are you going to light their battery on fire when you do this? And like even if you are, is that what they're expecting to happen? So like in this case, these are like doctors and nurses and shit. Like this is what they use their equipment for. Who gives a shit? On the other hand, something we had to be very sensitive to is that most hospitals have just ghetto-ass computers from 20 years ago. So are they capable of doing that number crunching? And so like that was like a realistic performance constraint that I had to work within. And then it's like, okay, well, it can do the number crunching. It just takes, every time you change something, it takes how long? Half a second, 5 seconds, 15 seconds? What's acceptable in that circumstance? And so my preference is always to push that down to the client for 2 reasons. One, like in aggregate, that stuff is computationally expensive, and like these are just commodities, and so you're just paying extra dollars to do those calculations. If you can offload that to your customer, that's thinking smart. The second reason that I prefer to do stuff on the client is that what's the slowest thing in any app? A network request. If I don't have to make a network request, because otherwise I change something, it needs to go to the network, tell it what I changed, it needs to rerun the calculation and then send it back to me. That's a laggy interface. Versus if I'm doing it all on the client, I'm only subject to how fast their processor can chew that. So it's usually my preference to do something like that. Reasons you wouldn't do that, think about if there's sensitive information that's involved with that. Because like with this, you have to have all those availabilities. Well, what if you're not allowed to see somebody's availabilities? That's like a security issue or something like that. Okay. Well, in this case, it was only hospital administrators that were like doing this for their employees. But if it's an employee who's doing this for themselves, it's maybe not their business what somebody else's availability is. So in that case, you have to do it on the server. It might be too slow. It might even running client side be too laggy. And like you can do way faster commodity computers than like your customer on a metered phone in Africa can do. So in that case, you push it to the server. You also might be dealing with something where, as we saw, I think it was today's fun fact with floating point math, you might be doing some math that JavaScript just can't fucking handle because JavaScript is super bad at math. In that case, you want something that's super good at math, like Scala or Python. And so you have some service that's handling that. But in that case, you're introducing the network request, so you're gonna have some lag. But it might not be bad lag. I mean, like, this is actually one of the neatest things, I think. So if I do some kind of search, all that predictive searching it's doing right there. So this is Firefox. Chrome came up with that. It's writing back to their server and like doing those predictions in real time. That's pretty fast. The reason that like that's a little is they're also logging all of that, and like that there's a pretty real privacy concern with that. So as Firefox is trying to stay competitive with Chrome, they are like, okay, people love that feature, but we also want to protect their privacy and we don't want to store this data. Because like that could get leaked or exposed and pretty. So the way that they do it is that they keep a local database of everything that you've searched for, and they run it off of that. And so they get the same like super fast predictive stuff without a network request. I think that's baller. Or Chuck telling me about how they did that. I love Mozilla. I think they do really good stuff.
Wait, the database is where?
On your computer.
Whoa.
Yeah.
Oh, like when you download Firefox, you're also downloading that database?
No, you're generating that database with your searches. And so it's able to do that predictive stuff off of information that you've provided it. And it's just keeping that in a database and running an algorithm to generate those predictions.
That's amazing.
Yeah.
Does that mean you frequently search random characters?
Yes.
Okay.
You goddamn right.
I was gonna say, I was definitely giving you some stuff back.
Cool. Any other questions? FP. Thank you very much.